Welcome to Brain Vision.
Hi everyone, so what we have is a rigid tank of volume equal to 2 cubic feet of saturated R134A refrigerant at 160 psi, of which 5% is liquid, the remaining 95% is vapor. There's a valve that's opened until all the liquid is vaporized, and this is a constant pressure process. So during this isobaric process, we are asked to find the total heat transfer. So what we're given is an isobaric process where the final pressure is equal to the initial pressure. So P1 is going to be equal to P2, which is going to be equal to the exit pressure of 165 psia. We know the total volume at the end is going to be 2 feet cubed. Now the total volume in the initial is also 2 feet cubed, but since 5% of that volume is occupied by the liquid and 95% is by the vapor, we can actually split this up into two separate terms. So the first will be V1F, which is going to be the volume occupied by the liquid, which is going to be 5% of 2, which is 0.1 cubic feet. And then we're also going to have a V1G, which is the volume occupied by the liquid, which is the remainder of 1.9 cubic feet. So from the R134A table, the saturated R134A table, we can find specific volume, internal energy, and enthalpies corresponding to the saturation pressure of 160 psia. So what we'll do is we'll find first the specific enthalpy. We'll see that the specific enthalpy leaving will be equal to Hg, which is equal to 117.20 BTU per pound mass. We'll find that the specific volume, V1F, is equal to 0.01413 meters cubed per kilogram. We'll then find the specific volume of V2, which is equal to V1G, is equal to 0.29339 meters cubed per kilogram. U1F, the specific internal energy, is going to be equal to 48.109, and the unit for that is going to be BTU per pound mass. And we'll also find the specific internal energy for U2, which will be equal to U1G, and that's 108.51 BTU per pound mass. So we can actually use the definition of specific volume to solve for the initial mass that's vapor and the initial mass that's liquid. So first what we'll do is we'll find the initial mass that is just liquid, and we'll call that M1F, which is equal to V1F over specific volume, V1F, and this will give us a initial liquid mass of 7.1 pound mass. Similarly, we'll do the same thing for the vapor. We'll say M1G is equal to V1G over specific volume V1G, which gives us a total mass of 6.5 pound mass. We'll again use a similar relation to find the final mass in the tank after every bit of liquid has vaporized. And that's V2 over specific V2, which gives us 6.8 pound mass. Now, if we do an energy mass balance, we'll see that the mass going into the system minus the mass leaving the system is equal to the change in mass of the system. Now our system is defined as the tank, and there's actually no mass that's coming in, so M in is 0. So all we have is that the mass leaving the system is related to the change in mass of the system. So now what we can do is say that M out is just ME, so minus ME is equal to M2 minus M1. And we can actually go ahead and say ME equals M1 minus M2 by just bringing that minus sign over. Plugging in for these quantities, we'll see that the mass exiting is equal to 6.8 pound mass. And that's the mass that leaves. So what we can do is actually calculate the total heat transfer. And we know that the energy coming in minus the energy going out is equal to the change in energy of the system. Now, as previously mentioned, our system is this rigid tank. So we have heat that is coming in minus energy that's leaving the system just in the form of mass flow. And that's going to be equal to the change in internal energy of the system, which we can write as M2U2 minus M1U1. Now remember that M1U1, so the initial internal energy of the system, we actually wrote in terms of the energy due to the gas and the liquid inside. So we can actually write M1U1 in terms of the quantities that we have and say that M1U1 is equal to M1F times U1F plus M1G times U1G. So if we just solve for Q, we see that Q is going to be equal to M2U2 minus M1U1 plus the energy due to the mass flow leaving the tank. So we actually have all of these quantities, and we know the value of all these variables. So once we plug those numbers in, we get a final heat transfer equal to 488 BTU, and that is our final answer.